We thought it was a software bug. Servers kept rebooting during the busiest hour, and every clue pointed to the app, until someone noticed the hallway lights dip every time a rooftop unit cycled.
Welcome to Built, Wired and Secured. I'm Alex Morgan. Today, that exact kind of mystery, what looks like IT but isn't, is what we're unpacking. Michael Harrington is here. Michael, glad to have you.
Thanks, Alex. Quick question to start. What breaks if this goes down? That line of thinking changes everything for operations.
Exactly. And listeners, when we say dirty power, we're talking about things that rarely make the incident board, but make equipment grumpy. Sags, spikes, harmonics, grounding oddities.
Right. Practically, you spot it as intermittent reboots, alarms with no clear cause, or lights that dim for a blink. Those are the operational red flags.
Lighting dims, like a flicker?
Exactly. A half-second sag when a big motor starts is enough to upset a server power supply or reset an access controller. Tenants notice the app first. Facilities notice the lights. You need both clues to find the match.
So, if I'm a facilities lead walking a floor, what symptoms should make me pause and call IT or an electrical contractor?
Intermittent equipment reboots, error logs with no recent updates, nuisance trips on breakers, and transient alarm activations. Also things that correlate with time of day or known mechanical cycles. Those patterns matter.
Patterns, got it. Let's talk causes without getting lost in theory. What are the usual suspects on campuses or multi-tenant sites?
Shared tenant loads, large motors or welders cycling are common. Aging or poorly maintained UPS systems show odd behavior under partial loads. Bad grounding and bonding produce stray voltages and communications noise. And sometimes the utility or transformer interactions, resonance, voltage regulation play a role.
So it's not one villain. It's often a combination.
Yes, and that means fixes should be prioritized, not reflexive. Start with understanding impact. Which loads are critical, which failures are acceptable for a minute, and which aren't.
Let's hack that decision process. Monitoring first, conditioning second, UPS strategy, then big capital like microgrids. Does that roughly line up?
Exactly. Monitoring gives you data, timestamps you can correlate with IT logs. Conditional fixes are surgical and cost-effective. UPS strategy matters, but bigger isn't always better. And microgrids are powerful but heavy. Save those for when your business case actually needs autonomous power.
Hold up. Bigger isn't always better on UPS? Say more.
Oversizing can mask battery health problems when the UPS runs at low load. Transfer logic can cause momentary blips when switching sources. Sometimes a small change, adding a few seconds of ride-through, or a line conditioner on a rack fixes the real pain for a fraction of the cost.
So leaders should test transfer curves and battery runtime, not just by capacity.
Right. Test under real load, time the transfer, and watch for micro interruptions. Those half-second events are the ones that hide from paperwork but break things in the field.
Give me a couple of quick, anonymized examples. Symptom, surprising root cause, and the immediate fix. Short and sharp.
1. EHR freezes at a clinic. Symptom, intermittent application hangs. Root cause, a lab centrifuge on the same panel causing sags. Fix, dedicated conditioned circuit for the clinic and basic power logging.
Wow, lab gear taking down patient records? That's a clear priority.
2. A campus with repeated false fire alarms. Symptom, detectors tripping at odd hours. Root cause, harmonic distortion from VFDs in the mechanical room. Fix, add harmonic filters and rebalance loads.
And the third?
Office tower, network closets lost connectivity nightly. Symptom, evening drops. Root cause, utility voltage regulation drift during peak. Fix, power quality meters, negotiate staged utility fixes, and add local conditioning to the most sensitive floors.
Those are the kind of solutions teams can implement without redesigning the entire electrical system.
Exactly. And a quick reality check. Microgrids are sexy, but they're not the answer for intermittent sags caused by a tenant's motor. They add fuel logistics, controls, and maintenance overhead. Fix the immediate power quality issues first, then escalate.
Good friction there. Microgrids aren't magic. For listeners who need immediate next steps, what's a prioritized checklist they can run this quarter?
1. Enable time-stamped power logging on panels serving critical loads. Get the data. 2. Correlate those timestamps with IT or alarm logs before replacing gear. 3. Visually inspect grounding and bonding during maintenance windows. 4. Identify large single-source loads on shared panels and consider dedicated circuits. 5. Review UPS age, runtime, and transfer behavior. Test under load. 6. Add targeted conditioning for chronic trouble spots before replacing major equipment. 7. Only then, if you need long autonomy, evaluate generators or microgrids with a business case approach.
That sequence keeps cost proportional to impact. Short data, then surgical fixes, then capital if needed.
One more practical tip. Make sure your handoffs are clear. When you bring in an electrical contractor, give them correlated event logs and describe the operational impact. It changes the conversation from, "we think something's wrong," to, "here's the pattern. Please test these scenarios."
Perfect. For folks who want a starting point, we've prepared a one-page power quality checklist that follows these priorities. Download it from the episode page and use it during your next inspection. If you need operational consultation, there's a contact path on the page as well.
And remember, when failures look random, ask, what breaks if this goes down? That focus makes the fix practical, not just expensive.
That wraps up this episode of Built, Wired, and Secured. Today, we dug into how power quality quietly drives failures and what you can do first. Monitor, correlate, and apply targeted fixes before overinvesting. Thanks for spending a few minutes with us. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world.